I showed you how to make a point and how to do collision with circular objects. Next, I'm going to draw a rectangle. To do that, inside the parameters there, it wants x, y, width, height, and optional radius. Okay, so I'm just going to start at 0, 0, 100, 100. There. I have drawn a rectangle, and it's at 0, 0. So its top left corner is right there at the top of the program window. So, like I said, this would be the x value there, yes, the y value, the width of the rectangle, and the height of the rectangle. Very straightforward, yes? Okay. Now, I want to be able to tell when I'm inside this rectangle. So I'm going to kind of put this maybe off a little more toward the middle of the screen-ish, 150, 150, and we'll say same there, 150, 150. There's my rectangle. Now, and to be able to tell, like when something happens, it's going to change color. Why don't we, so we don't use stroke necessarily. What that does is changes the outline color of the rectangle. Instead, we would use fill, like that. Okay, and that fills in our rectangle, whatever color we want. Okay, so I would like to alternate, I guess, between red fill or green fill. Okay, so let's make it the green fill if it is collision is detected. Okay, so then it would look like that. Yes, right. So what did I say? If collision is detected, that sounds like we got an if happening there already. So we know there's going to be some if action. Let's get our if statement in there. If something happens, do this. Yes. I'm just going to drag that right in there. Let me just add a little bit of space there. Okay. If, whoops. It did something I didn't want. Redo. If something, do this. There. And drag that in there. That makes more sense. If something happens. So I could say, basically if anything in here happens that makes this true. So I could say if true. There. It fills green, but then it turns it back to red right away underneath because it's reading this, makes this true, changes the fill to green, but then right away turns it back to red. No, we want it, if this is true, do this, otherwise do this. Okay, so that's a little bit different type of if statement. Actually, we'll say if whatever is true, do this, otherwise, but we don't say otherwise, we say else, like that, do what's in here. Okay, so let's drag that in there. So if true, let me space this out a little more. There, okay. If true, do this, otherwise do that. So now if this was false, it's going to do that, you see. So you could also say if 1, basically in the world of ones and zeros, 1 is true, and 0 is false, or you could make a comparison in there, if 1 is equal to, I'm sorry, and we don't just say equals, because that's the way that you assign a value to something. No, we say equals 1. Actually, it's equal. equal. There. In this language, in JavaScript. So if 1 is the same, that means that this is the same as that, right? If I wanted to say if it's not the same, I'd put an exclamation. like that. So if 1 is not the same as 1, well, we know that to be false, so that it delivers the false statement, you see. Or, let me undo that. If I could say, if apples is equal to 1, no, apples is not equal to 1. I could say if apples is equal to apples, yes, that is true, right? But if I said is apples equals to oranges, no, that's not true. See, so it's gonna get this. Okay, kind of made my point. Whatever is in here will equate. Okay, so we want to make it so if the mouse is in there, right? Okay, how are we going to detect if the mouse is in there? Okay, so well we have these values here: x value, y value, the width and height. I'm going to convert those to variables real quick. So we're going to say our var rect, our box. Let's call it our rect x equals. Where are we at? We're at 150 right now. 150. Okay. Yes. Same thing for the y. Here's a nifty trick. Instead of copying and pasting, I can hold down the control button and just drag over here, and it will copy. Haha, nifty. I can change that to a y, and now I have a variable ready for here. Let's get the x in there. Paste that there. Paste that there. Make it a y. Okay. Let's get our width. Again, I'm just going to make a couple new lines here. I'm going to copy this by dragging it here. Yeah. And instead of rect x, this will be our rect width equals 100. Yes. And I'm going to grab that and drag, copy, control drag. There. Cool. And, whoops. I want just to grab the width and name it height. H-E-I-G-H-T. There we go. Okay, and that is 100. Okay, so let's pencil those in to our height and position like that. There. Okay, so now if I change this to 60, yes, 60, change this to 40, there, see, I got this rect. And I want to detect if I'm in here. Okay, so first thing, I want to know if the mouse is inside here. First, let's start with the left side to begin with. I want to know if the mouse is greater than here, right? And all this is going to be, for any of this to do anything interactively, you're going to need to be checking constantly. So that means we need to run all of this inside of a draw function, basically. All of this. So let me see. I'm just going to type my draw equals. And all of this goes right in there inside my draw function. Okay. So now let me just tab in. Tab. There we go. Clean that all up. Good. Draw equals function. Ready to go. Okay. Now I can interactively check here with the mouse, right? Sounds like an if statement, yes? If, here we go, if mouse x is greater than, and I don't need to know the number, I have a variable that tells me where the left side, the x value of our rectangle is. I can use this and say if it's greater than that. Now watch, when I get past the left side, it turns green. Yes, and when I go back out, it defaults back to the else statement and goes right back to red. Very good. Okay, so now it's anywhere to the left of here. See, I can be like that. I can be like that, you see. So, okay, so now we got to define it a little further. Let's say, let's get the other side over here now, right? So, here's what I have. If the mouse x is greater than the rect x, right? Okay. Now I want to check make sure if it's greater than this and less than over here. Okay, I've showed you OR statements. Now we have an and statement. Okay, and in this case it uses two of those, and that says and. I'm just going to paste in what I just copied here. If I didn't mention that, I'd copied that. And the mouse x is less than. Okay, now I just made an impossible statement, right? It can't be greater than this value and less than that value, the same thing, right? So that's false, okay? Okay, so if it's greater than the rect x plus its width, you see. So here's the width. So rect x plus the rect width. Okay, so there. Okay. So now it's when I'm coming from this direction, if the mouse is less than this position here, 0 plus the full width. Okay, very good. Now we just need to get the up and down. Very much the same thing here. I could really start here and just grab all of that, copy this entire bit, and I'm going to go and like that, and just go ahead and hit return. It's okay, it can be on another line here. I'm just going to indent that a bit though. Okay, and okay, but what you can't do, let me just go back and here's what you can't do. I can't make a new line and then go and something. It won't accept that. Okay, that's just one of the nuances of it. Okay, I said the computer ignores white space in most instances. This isn't one of them. That and has to be at the end of this line, and then you add the return there, and you can continue on another line with some more statements there. Okay, now here we're switching to the Y. Everything is Y here. Whoops, I want a capital Y. So basically, let me just Y, and I'll click here, and Y, and I'll click here, and Y, and Y, and instead of width, I want height. I got the top, I got the bottom. You see, I could have done that step by step. Let me just remove this last bit just to show you, see, there's the top, but not the bottom. See, I have three sides active, like that, but not the bottom. Okay, let me undo. There. There is the basics of rectangular collision detection. Rectangular collision detection. There you go. Save that as rectangular collision detection.